Hello viewers, you are welcome to another video on vertical asymptotes. So in this video, we are going to consider the concept of vertical asymptotes, and I believe that it's going to benefit you a lot because this will help us to gain insight into the concept of limit, because it's only limit that we can use to explain the vertical asymptotes. Yeah, let's consider the first graphical illustration as we can see it on the screen. The question is this: what is the limit of this function if x tends to a from the negative axis? Now look at that blue arrow. You will see that the blue arrow is coming from the negative axis, is coming from -2, -1 is 0, 1, up to it will touch the line. You know, that line is the function f of x, and as the arrow blue color is coming, it's going to hit the line. And as you can see that the line is actually moving to the positive infinity. Yes, so we can say that the limit x tends to a from negative axis of f of x is equals to infinity, which is positive infinity. So let's consider the second question now. For this particular question, we are interested in the limit of f of x as x tends to a from the positive axis, which means that as the x is coming from 5 to 4 to 3 to 2 to a, what is the limit? And as you can see, the red arrow is also coming from that axis too, and the red arrow will touch the curve f of s as that line is going to positive infinity. Third question, or perhaps you can say the third illustration. So here, what is the limit of f of x as s is tending to a from the negative axis? If you look at this line very well, you will notice that as the blue arrow is coming from the negative axis, it will definitely touch the curve f of x at that part, which is tending to minus infinity. Exactly, look at it very well. You will notice that as the arrow is coming from the negative axis, from the negative axis, it will touch the curve, it will touch the line f of x, as that f of x is going to minus infinity. So let's go to the fourth illustration, which is going to help us to understand the concept of vertical asymptotes. What we are interested to know in this particular illustration is that what is the limit of f of x as s is tending to a from the positive axis? And if you look at this very well, you will see that red arrow again that is coming, but the red arrow will only touch the curve f of x as it touches the vertical asymptote a. Meanwhile, the curve f of x is actually tending to negative infinity. Of course, you can see that it's actually tending to negative infinity. Okay, so let's consider this question, the tutorial question 2. It has A, B, C, D, and E. So the first one here is asking that, what is the limit of this function as s is tending to 3, to x as x is tending to -3? And if you look at it very well, you see that it's very simple. What you need to do is this: look at the x-axis. Where is -3 there? You can see -3 there. Then the point is this: what is the limit? You will notice that the limit of as x tends to -3, either from the left or from the right, is infinity. Then tutorial question 2b. What is the limit of the function a of x as x is tending to 2 from the negative axis? So if you look at it very well, you will see something there that that is b. And if you look at it as s is tending to +2 from the negative axis, you will notice that the curve, which is the red, which is a of x, is also tending to minus infinity. Question 3. What is the limit of the function a of s as s is tending to 2 from the positive axis? So if you look at it very well, you notice that as the arrow is coming, it's going to hit the curve. Okay, it's going to hit the curve, or let me say it this way: as the arrow is coming, tending to 2 from the positive axis, it's going to hit the curve at infinity. Or perhaps it's going to hit the curve as the curve is tending to infinity. Of course, that is tutorial question 2c. that what is the limit of a of s as s tends to 2 from the positive axis? And the answer is infinity. So tutorial question 2D is asking us that what is the limit of a of s as s is tending to -1? Remember, this -1 here is not asking maybe it is from left or from right. Okay, it's just asking that as s tends to -1. And for us to give the answer to this, we must consider the left hand limit and the right hand limit. So let's go and look at the graph very well. Can we see there where x is tending to -1? Can be, as you can see, -1 there. You can see the arrow now. The point is this: as s is tending to -1. So what is the limit? The limit is -infinity. If you can look at the arrow very well, you will see that where we see D, that one is telling us that both the curve from the left, from the right, both of them, they are going to -infinity. So the last question now is asking us about the vertical asymptote. Because if you look at this graph of a of x, it has like 3 asymptotes, vertical asymptotes rather. It has 3 vertical asymptotes down. The question is asking that what are the asymptotes that we can see there? So you will notice that when x is equals to -3, there's a vertical asymptote. Also, when x is -1, there's another vertical asymptote. And lastly, when x is equals to 2, there's another vertical asymptote. The second thing we're going to consider now is the graph of y is equals to 2x divided by x minus 3. If you remember from this, if you look at this function very well, you will notice that x can never be 3. Do you know the reason? By the time you put x equals to 3 inside this function, you will have undefined. So which means that when x equals to 3, there will be a vertical asymptote. Of course, definitely. Because if the function is undefined at x equals to 3, it means that something is happening there. So that x equals to 3, if you are moving closer to it from the left, the function is divine. If you are moving closer to x equals to 3 from the right, the function is divine. The only problem is that at x equals to 3, the function is undefined. So which leads to the fact that we need to understand the limit of the function from the left and from the right. So let's look at the first question now. So the limit of the function as x is tending to 3 from the positive axis, you will notice that the arrow will touch the curve as the curve is going to the positive infinity. If I may say it again, this is what I'm trying to say now, that the limit of the function 2x divided by x minus 3 as x is tending to 3 from the positive axis. And as you can see that red arrow that is coming, the red arrow will only hit the curve as the curve is going towards a positive infinity. Let's consider the second aspect of this question. So the second aspect is talking about the limit of the function as s is tending to 3 from the negative axis. So the best way for us to understand this is to look at that blue arrow. And as you can see, that as the arrow is coming from the negative axis, as it moves towards s equals to 3, it only hits the curve, as the curve is tending towards a negative infinity. So let's proceed to the next one. Here we want to consider the graph of lane x. I think you are familiar with this before. Okay, if not, let's look at it again. As you can see on the screen, that is the graphical illustration of f of x is equals to lane x. One thing about this graph of lane x is that it also has what we call vertical asymptotes. Yes, of course, it has a vertical asymptote, and that is at x equals to 0. And if you look at this very well, you will notice that as x is tending towards is 0 from the positive axis, as you can see, look at that red arrow. You will see that the red arrow is coming from positive axis going to x equals to 0, and the arrow will only hit the curve as the curve is tending down deep into minus infinity. So the next illustration now is the case of tan. Of course, you remember when I was teaching the physical function of real variables, I call your attention to the issue of vertical asymptotes, that there are many vertical asymptotes in the case of tan x, just because we have tan x to be signed over cos, and cos will be 0 at many points. Okay, you remember, if you look at your lecture note, you will see the graphical illustration there. So this time around now, I want to consider the vertical asymptotes of this particular tan x. But let's look at this. If x is tending to pi over 2 from the negative axis, so what is tan x? Look at it very well again. What is tan x? If x is tending to pi over 2 from the negative axis, you all agree with me that the function of tan x is actually tending to positive infinity. Let's look at that arrow. So the second aspect now is what is the limit of tan x as x is tending to pi over 2? But we are talking about the sided limit from positive axis. So for this case now, we now see that the tan of x is tending towards negative infinity. So look at that blue ellipse line that is zooming. You see that it's telling us that if the function is coming, if x is coming from the positive axis, it will only hit the function f of x, which is equal to tan x, as that tan x is tending to minus infinity. So let's go and look at the tutorial question that we're going to answer online.
We share
tutorial questions and answers.
It is all about understanding facts and sharing with others.
Learning continues. We are learning to know, understand, and share with others.
Please subscribe to our channel if you like our videos.